All right, guys, today I'm going to show you how to 3D print ULTEM 9085 on our 22 IDEX. Here at Vision Miner, all we focus on is the high temperature materials like ULTEM and PEEK and PPSU, and we manufacture this machine specifically for that. So we're going to go right through the cheat sheet today. We're going to go through drying your filament, which is the first most critical step to any high temp filament. And then you're going to heat up the machine and the plate, apply some nano adhesive, some bed adhesive so your part stays stuck down, and then move on to the web control. I'm going to show you how to do all of that. And then we're going to slice the part in Prusa Slicer using the profiles that we provide for most materials right there on wiki.visionminer.com, where you can find everything else about this machine, how to use it, how to fix it, and all sorts of stuff. And of course, we're right here in America, so you can always give us a call, shoot us an email if you want more info, or you have questions, or you already have a machine that you bought and you want to figure out how to do a more complex part. So this is the beginning of a series that we're doing on slicing parts for high temp on the 22 to help you and our customers with these, frankly, sometimes very challenging materials, but the results are worth it. So the next part that you're going to learn about is checking the G code, loading the material, hitting print, and then watching that first layer for a bit. And then once it's done, you let it cool down a little bit, take your part off, and you're good to go, ready to start the next one. That's the overview. Let's dive right in. So, the first thing you want to do, guys, always dry your material. Inside this vacuum chamber, which we do sell at visionminer.com/dry kit, is a spool of ULTEM 9085. We sell all these materials at visionminer.com/materials. How many plugs could I get into the first 5 minutes? I don't know, but we are a business. This is how we keep the lights on, helping you guys learn stuff about this technology. Basically, if you're gonna do a print in ULTEM 9085, or any of the high temps, you're gonna wanna dry your material generally for around 4 to 8 hours. A great rule of thumb is putting it in the oven the night before, and if you got a vacuum oven, set it on a timer so that by the time you come in the next day, it can be cooled down. All these materials are hygroscopic, meaning they absorb moisture from the air. So if you take a spool out and you set it next to the printer and wait 10 to 20 minutes before you load it, it's soaking up moisture that whole time. And that's gonna cause voids, and it's gonna cause bubbling, and just all sorts of stuff that you don't want in your part. So it's really important that this first step of the process, you get it down pat and you nail it, because that's gonna affect the entire rest of your part and the success of the print. So always dry your filament. And then a great way to store it, or even let it come down to room temperature, is in a vacuum chamber. Now we sell these kits. We also have vacuum ovens, but this is great because we had it baking overnight and slapped it in here a couple hours ago, so it's cooled down a little bit, but it's ready for this filming right now. So the next thing we're gonna do is we're gonna actually heat up the machine and get it preheating before we actually load the filament, because if you're doing a big, long part, you really wanna let the machine heat soak. Metal parts shift over time, and if you start at room temperature and you go up to 100 Celsius in the chamber, it's gonna take anywhere from 30 minutes to an hour for all that metal to slightly change shape. Now, it changes shape like a tiny amount, like a hair, but that hair is the same thickness as your first layer, and so that can throw off the entire part. So you really wanna make sure to heat soak. If you're doing bigger parts, today we're just gonna run it and gun it because it's a pretty small part, pretty simple, pretty straightforward. So first things I'm gonna do is I got the machine turned on, and I'm going to open up any web browser and go to the machine IP. And here we go, it has loaded our interface. Now this is where you're gonna do most of the work with the machine when you're changing temperatures, you're running processes, doing baby stepping if you need to on that first layer. Everything's through here. And you can also use this on a laptop, a tablet, or even your smartphone, which most people have, as long as you're connected on the same network. Now, if you're in a secure location, like your military, government, something like that, the Wi-Fi is completely removable. Literally, it's a module, you pull it out, or we can pull it out before we even ship it to your facility. So we've got you covered on the secure aspect of the machine. You can also print over Ethernet and do all sorts of different stuff, but that's locked in, good to go. But most of you out there will be using the web interface. Now, it's not cloud web, it's all local. So we're not like logging into some system and monitoring all your data and everything. It's completely separate. It's all totally under your control. No worries there. So we're going to go in here, and the first thing I'm going to do is set the chamber temperature. We're going full bore here, so I'm just going to set it to 100. And then the bed temperature, we're going to set to about 160 for this print. And you'll see there it automatically changes it from off to active. So we're just going to set it. And then we're going to go in and we're going to do the load filament function. Now, personally, and a lot of people like just manually loading filament. It's easy, it's straightforward, you can see everything, but we do have a function to automatically load. So let's go ahead and do that. The other thing is, before we get to that, the build plate. Before the build plate gets too hot, you want to apply some nanopolymer adhesive, or your bed glue of choice. This stuff right here, we made this back in 2017, 2018. Did not intend to sell it. It just happened to work for frickin' everything. So if you're using a bamboo and printing PLA, this stuff will work for months, one application. And if you're doing the crazy high-end stuff like PEEK or ULTEM or even ABS and nylon, it still blows me away how well this stuff works. It's kind of ridiculous. It's like, frankly, it's nuts. Comes in a bag like this. Open that up. Got my bottle here. And of course, a little brush. Now, we have different things coming to replace this brush, but you'll have to subscribe to see that when it comes out. There's a lot of different ways to apply it. You could use a paper towel, you could use a squeegee, you could use a roller, you could use a foam brush, whatever you want. This does happen to be the most efficient way, using a little acid brush like this. You do want to watch for little hairs that might come out and whatnot. Usually doesn't affect much. You just want to get that spread out. I like drawing a little circle on the plate around where the part's going to go and then just spreading it out evenly and just getting a good coating in that area. Now, if you're doing the whole plate, obviously you want to coat the whole plate. Since we're doing high temp material, we're going to reapply before each print, at least in the area that we printed. And so I'm just going to be relatively thorough in spreading it out, and we're good to go. So while it's still wet, I'm just going to throw it right back in the printer. And we're going to let this whole thing heat up and come up to temperature. I'm going to tighten down the four corners, the build plate screws, so the build plate doesn't shift during printing. We definitely want to make sure to do that. It's always fun chasing down a layer shift that was actually the build plate shifting. All right, so we got that out of the way. The next step is going to be slicing the part. Let's do some slicing. So we have today, here's our slicer. You can just press this little button up in the top left and pick your part. We've got part one. It's a little bracket. I'll tell you what it's for at the end of the video. But for now, it's just some sort of bracket that's holding something. 90% of the parts we do here at Vision Miner in our print service or that customers are printing are like, I mean, it's the boring stuff that's interesting. Like, it's just a very basic bracket, but it's going in a nuclear reactor. That's the kind of stuff you get with high temperature materials. Really, really good time. So I've got my part. It's at a crazy orientation because it's a 3D scan of a part. So it's actually a replacement part that we just used a free scan combo and scanned the part, exported an STL, and we're good to go. Great tools to have around. We sell those at visionminer.com/scanners. So if you need a 3D scanner, check that out. So I'm going to use the place on face tool. Since it's not oriented properly, you can click this over here or just hit the F key, and it's going to give you all these little areas that are faces. So even this bottom part isn't perfectly even, and I'm just going to click that one, just pick that one, it's pretty close. And then to make sure that I've got a good surface on the build plate, I'm actually going to use the move tool, which is this top one right here. Hotkey is M, and I'm going to lower it down below the build plate. So you see how it gives you a little cross section there? So I just want to make sure that I've got a good solid area. Looking good there, good to go. And then if you're OCD, then you can adjust this to make it nice and square with the build plate as well. Totally unnecessary, but why not, right? Okay, so now that we've got our part oriented. Let's look at what's gonna happen. Now we have this overhang right here, but it's at a 45-degree angle, which means we don't need to put support material. If it was a lot more tilted, or if it was going out at a sharper or smaller angle, then you'd want to use support material there. On this one, it'll be just fine, but we also do have this overhang up inside of there. Now we could just let it bridge and not throw any support in there, but this part does need a square area, so we're just gonna add some support because it should be pretty easy to remove out of there. So first thing I want to do is select my machine profiles. Now we're already set up, but I'll show you what we did. On here, you can select the different modes. If you want to go into straight production and print in duplicate or mirror mode, we have profiles for those, but we're using a 0.4 millimeter nozzle and standard mode. We're just printing one part, so I'm going to select that, and then the print settings, we have the detail or draft or flexibles or multi-material soluble support speed mode. If you want those bamboo speeds, don't expect it to be super strong, but we've done some tweaking in there. Standard or high temps. We're gonna use the high temp profile since it's ULTEM 9085, it's a high temp material. And I'm gonna discard any of those modifications that were done. And then in the filament, we're gonna go ahead and just select PEI 9085. Now, we dialed these in on mostly 3DX Tech brand. You can see we've got some Victrex and some Fibron and other stuff there, but for the most part, it's ULTEM 9085. Most filaments are going to be pretty similar, and at the very least, it's a great starting point if you're using a different manufacturer's brand. That is one of the things with the 22 IDEX. It is an open material machine. We don't lock you down to having to buy our material and get the RFID chips and everything like that, and gouge on the price like some other companies out there. For the price of what it will print, it's an absolute crazy good deal, and it's totally open. So you can print with any 1.75 millimeter filament you want that you can make, that you can possibly dream up. So we're just going to select 9085, and I'm going to discard any of these, and we're going to go look at the actual settings. All right, so let's just do a preview and see what happens. Okay, so we've got our part there. Let's go into settings and go to support material and do auto-generated supports, because we're probably going to want a little bit of support in that little nook right there. And so we'll click here and say slice now, and it's throwing some little tree supports in there. Okay, not bad, not bad. Are those going to be difficult to remove? Should be all right. Yeah, a little pair of needle nose pliers like I got right here. That should do the trick. So we'll just leave that as is. Now, when you're examining this G-code, there's a couple different things to look at. Obviously, on features, the feature types here, it's all color-coded, so you can see the bright green is the support material, the dark red is the internal infill, and then you've got your external perimeters, your regular perimeters, and it's all just something to look at. A lot of the times, depending on how the part's made or designed, if it's done in CAD or if it's a scan or it's just something you found off the internet, then there can be little weird things going on. So you always want to look at your slice. And you can see all these little blue lines going around here. It's good to look at those to see travel moves. But really, a lot of this stuff will come into play after you print the first part. If there's weird stuff going on in your part, you can come back to this and look at it and see, oh, there's a ton of travel moves in that area, and that's why there's a bunch of blobs on that outer perimeter or something like that. So we'll just quickly go through all of these. You've also got the actual speed. So you can see most of this part is in the blue and green, a little bit of yellow. So we're getting up to 150 millimeters a second in some areas, mostly 120 to 90. And then all the corners are getting down into the 30 to 40 range. So that's something good to know before you print. We've also got fan speed. Now, I grew up in the days of the FunMat HT when you would just go super slow on everything and use no cooling fan, but that presented its own challenges, and not every part was possible. A lot of them were, but it's kind of a craftsmanship thing. Here, though, at Vision Miner, a lot of stuff's been developed, and we've, depending on the situation and the application of your part, you can use cooling fan. It's already a 100C chamber, and with high temp, especially if you're trying to go faster like we are here at 150 millimeters a second, different areas can have different thermal mass, especially around retractions, and sometimes it'll overheat and cause issues that you don't want to see. Sometimes it won't be hot enough, and if you had too much cooling fan, then your layer adhesion is going to suffer from that. So it's always weighing a balance of, do you want a prettier part, a stronger part, an uglier part, or do you just need the chemical resistance and it's not taking any mechanical load? There's a lot of different things to consider. So always, always, always know what you want out of a part before anything else. So for this, let's actually go into the filaments menu, and we're going to go to the cooling tab here, and we're going to enable dynamic fan speed. So I'm going to check that box, and then I don't want 80% fan, but I do want a little bit because on that bottom area, it's a small part, it might overheat. So let's just set everything to 40. So it doesn't go over 40%, but we get a little bit of cooling fan in there. And let's go back and see what that looks like. Okay, ooh, yeah, see how that changed right there on that edge? Now we're still getting 80% fan on that area. So let's just go to maximum. I'm gonna set it to maximum of 40 because I don't want that much cooling. Slicer again. Okay, now 40 is the top. So we'll get a little bit of cooling on that back edge, but should be all right. You've also got overall temperature, so you can see if it's changing temperatures throughout the part, the volumetric flow rate, so we're getting around 11 or 12 millimeters cubed per second on some of these areas down here, and then other areas where it slows down, then you're getting less. And layer time, so the longest layer is going to be the top layer there, and then the rest of them are very quick. Gosh, that thing is moving. It's estimating 1 second per layer in this whole upper spine. That's very wild. All right, cool. All right, so we'll go back to feature type. Don't want to overload you here. All right, so we've got our slice. The other thing I want to do is get rid of a brim. As long as you're using this stuff, you pretty much, for the most part, don't need a brim. Brims are annoying because, especially in high temp, you got to peel them off the part, and the edge of the part has a just nasty edge, and it's just more post-processing. I want to be able to take this, pop the part off the plate, and throw it straight into use. I don't like having to do brims, and thanks to nanopolymer adhesive, it holds this freaking stuff down like incredibly well. So I'm gonna risk it and put no brim on there, and then if we find something that does curl up, I prefer lily pads anyway. And we've got a whole video on that, so go check that out right here on the YouTube channel, if you're on the YouTube channel seeing this. But go to youtube.com/visionminer and check out that lily pads video. Some people call them mouse ears. It's a great function, but I'll leave that for later. Okay, so there's one more thing I want to do here is throw in support material into the part itself. Why, I don't know. There's a little overhang in there or something, and so we're just going to go in and do a support blocker real quick. So I'm going to click this button over here, which is the paint on supports, and then I can hold, I believe it's command. Oh, no, what is it? I'm going to hold option. Nope, I'm going to hold control. There we go. And I'm going to paint red over that area so that it doesn't generate supports. So now we go back in, we slice, and you can see there's no weird little areas. We do see that overhang there is what was causing that, but it's a 3D scan and it should be fine. It doesn't need to be a super precision part for this one, and I'll explain why again later. But here we go. I think we're good. We're set. I'm just going to export this G-code. And you'll see it names the file with the part, the number of grams, how long it's going to take, which is 34 minutes in this case, the layer size, the nozzle size, and the tool that it's going to use to print, and then, of course, the material at the end. So I'm going to save that, and then I'm going to go back into Duet Web Control. Now I can upload and start with this button over here, or I can go to the jobs and click Upload G-code files here. So I'm going to go into there. I'm going to find my G-code. Let's do the one from today and open. Now it's uploading the part, and I got to load my material. So this material's been sitting in this chamber for about an hour. I can still feel it on the bottom. It's still a little bit warm. That's totally okay. So I'm going to click load filament on the left head, and I'm going to select PEI 9085. So that's basically just a temperature. It knows what temperature it needs to go to extrude it, and we're going to go ahead and take this spool out. All right, now the timer begins. This spool is going to be absorbing moisture from the air for every second that we leave it out. So I'm going to be quick with this one. Now, let's load her back up. All right, and I saw the filament go up and around, down into that tube on the top, and it's ready to feed the filament. So I'm going to hit start extrusion. I'm going to watch the nozzle to see it start extruding. And I might even give it a little extra help right here. Oh no, it's going. It's good to go. All right, so I'm going to take my little tweezers and I'm going to just pull this out. It's going to purge a little bit of material. We can see we got nice and dry filament because there's no bubbles or anything. It's not curling up a whole bunch. That's exactly what we want to see. All right, yes, filament is visible. So now it's going to stop extruding. It's going to wipe the nozzles off. I'm going to close the door back up, and there's our purge. So if you're doing a huge part, you're going to want to wait after this point. And you could have done this actually before the whole process. You can load the material at any time, but we like doing it in a hot chamber so that it's lower humidity, so you're not absorbing a bunch of moisture while you're waiting for it. But we can let it heat ramp a little bit up. We're at 69 in the chamber, and I'm just gonna run with it because this is a very small part and we don't need the whole chamber to be super hot. And well, let's just see how it goes. That heat soak should be about good enough. The frame's pretty warm, so things shouldn't shift around too much. So I'm gonna scroll down here and see the one that I uploaded today on 6/22 of all days to do a 22 tutorial. And I'm just going to click it and say yes, start the print. All right, so it's going to take the bed, the build plate, the bed heater up to 170 Celsius, and as soon as that hits, it's going to start the print. So we'll just hang out for a little bit, maybe take a sip of your favorite drink, and wait for it to start, and then we're going to watch that first layer. Okay, so you saw it flash. That means the preheat is complete. It gave me a little notification here on the window, and it's going to start the process. Now, this is designed, we have a mechanically self-leveling build platform, so every time before a print starts, just in case maybe the heat soaking did shift some of that metal or something like that, it's going to make sure that it's absolutely flat and level mechanically, and then it's also going to do the mesh probing around so that if you have a build plate that's maybe not perfectly flat, it can still compensate for all of that. So it's going to go through that process now, which takes about a minute. Laying down pretty clean. Now you can always watch that first layer. I see that those lines are very close. It's not plowing like a snow plow. It's also, I don't see any gaps in between the lines, so that's just about right. All right, so first layer is looking good. We're just gonna let it do its thing for the next 34 minutes approximately, and we'll come back to a finished part, take it off the plate, and be done. And then I'll tell you exactly what that part's for. All right, so the part finished. It dropped the build plate down there. Now, you're gonna want to wear hot gloves when doing this part, but I'm just gonna reach in, unscrew the build plates, just nuts, and check out the part. All right, here we go. Now, you'll notice the screen shows that there's a HEPA filtration. After a print finishes, the filters inside actually just circulate the air to clean out any additional fumes or anything like that. But here we go. Very nice. All right. Part's actually looking pretty darn good. Boom. Just like that. The glory of nanopolymer adhesive. Let's take that. Still a very hot build plate. very hot. I'm gonna set that down there real quick, and let's check out our part. Part's looking darn good, man. Give it the old bend test. Seems strong. And let's go in there and get that support material out. Some needle nose pliers right there. Very good. You just tear it out. That is one thing with high temp materials. You could use a breakaway or soluble support material as supports, but it's going to slow your part down. It's going to change the dynamics of the layer adhesion because each layer temperature as it's extruding the next layer makes a difference. So if you're swapping between hot ends constantly, it's variable, you know. So usually we'll just do the same material as support. Oh yeah, that whole little interface layer just came out. Grab that last little bit inside there, and then if I need to, I'm gonna go in there with a knife. There we go. So this is our final part. Very good, ULTEM 9085. It's that easy. We'll be doing a whole series of these videos with different parts, with different materials, just to show you guys a full workflow on different types of things on the 22 IDEX. So to let you guys all in on what this part actually is it is an industrial part that does see a lot of chemicals and frankly a little bit of biological warfare. It is a household part, and it's actually for my brother's toilet seat. He sent me a part and said, hey, can you print me a new one of these? If you could scan this and print it, that'd be super helpful. So I said, yeah, why not? After all, the first flight certified ULTEM 9085 part by the military was the, I believe it was the Marine Corps, did a toilet seat. So how appropriate for our first tutorial to be a toilet seat part. Anyway, thank you so much for watching. Have a positive rest of your day, and we'll see you on the next one.